Hello everyone, let me welcome you back to the Gillespie's online classroom right here on YouTube. My name is Derek Gillespie. I'm a teacher at Monroe College in St. Elizabeth in Jamaica. In this particular video, created specifically for students of 4th form or maybe 5th form doing CSEC or CSEC geography, we will be looking at the topic mass wasting or mass movement. I'll be combining a few video clips from other teachers, and as these video clips are combined, after watching all of the video clips involved, it is my hope that you will benefit from the various approaches to the topic mass wasting. Welcome and success to you as you study the topic mass wasting or mass movement.
Mass wasting. The large-scale movement of loose material derived from weathering of bedrock down a slope is known as mass wasting. It is also called mass movement. The term mass wasting is coined due to two reasons. One, the loose material is actually rock waste. And two, the total movement down the slope on account of gravity causes the waste of rock debris in higher slopes. In mass wasting, the presence of water, wind, and glaciers are contributory factors. But the movement is basically on account of gravity. The steeper the slope, the more rapid is the movement. Various processes are involved in mass movements, such as fall, creep, slide, etc. All these processes can be divided into two categories: slow movement and rapid movement. In slow movements, gravity is the main factor. Water plays an important role, but since the movement is down the slope, presence of water may not be an important factor. Slow movements can be divided into two main types. The first type is creep. The slow downhill movement of debris is called soil creep. It may take place in the form of soil creep or rock creep. Soil creep involves fine weathered rock debris, while rock creep involves unweathered block of rock. Rock creep is not affected much by seasonal climatic conditions. It is affected more by distortions and bends in rocks, which offer resistance to gravitational pull. On the other hand, seasonal climatic conditions play an important role in soil creep. The second type of slow movement is solidification. In this type, water mixed with soil forms clay, which moves as a thick viscous fluid. It is more dominant in certain glaciated areas. In rapid movements, water is the main factor. There are four major kinds of rapid movements: landslides, earth flow, mud flow, and sheet wash. Landslides are most common, significant, and also observable. Landslide is the only exceptional rapid movement in which water is not the main factor. Landslides involve both rocks and soil. Their movement is characterized by a sharply defined shear plane. Shear plane is a surface which breaks off and on which movement takes place. Landslides take place when a support in front of a rock or mass of debris is removed by natural or artificial forces. The downslope movements occur in many ways. The first is fall, in which under the influence of gravity, rocks or the fragments fall down instantaneously from steep hill slopes. The second type of down movement is slide, in which the downward movement is along a certain path. Most landslides, however, occur rapidly. Landslides are often triggered by earthquakes, heavy rainfall, or by wind action. Earth flow is the movement of waterlogged material down a slope. Earth flow is common in areas having rich alluvium soils and on hillsides. In mud flow, water content is more than in earth flow. The debris is transported by the stream and rivers as mud. Mud flows occur in areas where vegetation is not present and slopes are steep. In arid regions with steep slopes, mud flows are common during rainfall. Sheet wash involves the rapid movement of rock debris or soil saturated with water-like viscous fluid. During soil erosion, large sheets or layers of soil are removed by agents of gradation like water, wind or glaciers. It is termed a sheet wash. On account of deforestation, the sheet wash has affected many parts of the world. Mass movements or mass waste create varied landforms such as meanders, terraces, scars, ripples, escarpments, mesas, etc. Landslides on Himalayan hill slopes have created many lakes. Because of a wide range of variation in mass movement, the topographic features also vary in size and shapes.
Alright, while the summary of the introductory video clip is being displayed on screen, I would advise that you pause the screen and make note of the summary points. Alright, students, so that was the first introductory clip. My advice is to make sure that you watch all clips and you compare the information being given and related to what you're studying in class. Here we go with the second clip.
Hi everyone. So our next topic that we are going to cover is what's called mass movement. So our learning intentions for this topic is we're going to be able to explain what mass movement is and why it happens. We are going to be able to describe both slow and fast mass movements using examples of each, and we're going to investigate the impact that mass movement can have on people's lives. So, what is mass movement? Okay, so mass movement is the movement of loose materials from the earth. So examples of these are like soil, stones and mud, and together they're called regolith, and they move down a slope under the influence of gravity. Okay, so now we're going to look at what actually causes mass movement to happen. So it's influenced from the following 4 factors, okay? So the first one is a slope. So the steeper the slope, the more likely that mass movement is going to occur. Secondly, we have vegetation. So what this means is like the roots of trees and plants basically hold the soil. So when they are cleared away, mass movement is likely to occur. Okay, so what that means is with the soil, everything that's holding, if they become loose, then that means there's more likely that it's going to start moving. Next, we have what's called water, or another word for that is precipitation. So we're going to see that word an awful lot from now on, okay? And what that is, so heavy rainfall, it's going to make the soil heavier and easier to move downhill. And this will act almost like a gel or a lubricant to make it all move together. And then lastly, we have people. So work carried out by people, such as digging, drilling, will actually disturb the ground, which makes the material, the regolith, really loose and will cause mass movement. So under this topic, we have 4 different types that we're going to look at in more detail in the later slides, that are the different types of mass movement. So the first one is called soil creep. And it's a very slow movement of soil, and it's the slowest type of mass movement. Secondly, we have mud flow, which is gentle to a steep slope, and it's quite fast. Thirdly, we've got a landslide, which we would have heard of before in our volcanoes and earthquake topics. And this is a very steep slope, and again, it's very, very fast. And lastly, we have a bog burst, which is again gentle to steep slope, and it may be fast. Okay, so this information box is quite important to remember. So we have our 4 different types of our mass movement. It tells us what kind of slope or gradient that it has. It tells us, is it wet or dry? And again, lastly, it has the speed. So definitely take note of this. So now we're going to look at the different types of mass movement in more detail. So as I said before, soil creep is a very slow movement of soil, and it's generally about 1 centimetre a year. And this is the slowest form of movement, okay? So water and gravity, it causes the soil to move slowly downhill. And this movement is shown in features on the surface, so we can actually see it. And we have different types of evidence of soil creep, so we know that it's happened. The first one are like fences and trees are bent, they're curved, generally downhill. We can see that walls collapse because of pressure building up behind them from the soil moving downhill. And soil creep is faster at the surface and slower deeper down. Okay, so we have a bit more information on this slide again regarding soil creep. Looking at the diagram, you can see that there are cracks in the road. We see the telephone poles are tilted. We see that the walls have collapsed because of pressure built up. Then a new term that we have, it's called terracets, and what they are, they look like actual steps or like lines and lines. I kind of call them like lines and wrinkles that you see on the soil and on the surface. We see that the trees can bend, and as a result then they grow at an angle. So as I said, you can only see the evidence of soil creep on the surface. The next type of mass movement we have are mudflows. Okay, and mudflows are fast movements of mud down a slope, and these may be caused generally after heavy rainfall or by volcanic activity. So the lava from the volcanoes can melt the snow, which then create a river of mud. And as on the third point, it's the fastest type of mass movement, which has speeds of up to 100 kilometers per hour. So think of the maximum speed that you can go down the motorway in your car. Well, the mudflows can travel at the exact same speed. Now, I've put a link up for a video. It's called Mudslide Mayhem, and it's a National Geographic video, and it shows a mudflow that happened in Colorado in the United States. So I highly recommend that you give it a watch, that you can see the damage that it can cause. So you've seen from the video of Colorado the sheer damage and the speed and the destruction that a mudslide can actually cause. So we're going to look at, this is also in your books, another case study. So this is a mudslide that happened in Sri Lanka in 2016. So as I said before, my previous slide, mudflows generally happen after enormous amount of rainfall or precipitation over a period of time. And this is what happened in Sri Lanka. We had heavy rainfall over a period of a number of days. And very shockingly, 134 people died after the mudflows rushed over several villages, okay? And you can see in the picture at the bottom, so if you look at the bottom of the slope, that was once a village that is now completely covered. So 60 houses were completely buried, and over 350,000 people were displaced from their homes. So if you think about what we covered in when we had the volcanic eruptions and the earthquakes, the amount of people that lost their homes, well, it's the exact same for mudslides. So heavy rain, it saturated a nearby hill that you can see up the top, and then the clay mixed with the water produced the mud flow, which sped downhill very, very quickly. And as I said, like, victims described it as a huge sound, like a plane crashing into earth. So you can see the sheer damage and the destruction that a mudslide can cause. What I'd like you to do now is you are going to fill in the blanks using the keywords in the box above. So you have 5 words that you need to fill in. Now, just to note, you will be doing fill in the blanks for landslides and bog bursts. So this box of words is going to be used for the 3 topics, or the 3 types of mass movement. So from this box, select the keywords and you're going to fill in the blanks. So the next type of mass movement that we are going to look at is what's called a bog burst. And bog bursts are fast movements of bogs down a slope. So the bog may be loosened by heavy rainfall or by work on a mountain wind turbine when vegetation is removed.
Now let me point out here that this part of the study you can know for general knowledge purposes, but for CXC and CSEC students in the Caribbean, this would not be relevant to your study. So I will be bypassing this aspect and move on to more relevant aspects of the study.
The last type of mass movement that we're going to look at are landslides. And landslides are rapid movement of loose rock and soil, also known as regolith, down a slope. And these landslides are caused by undercutting, which is the wearing away of material at the base. We have coastal erosion and earthquakes. So heavy rain can lead to landslides because the soil is now loose. Landslides can cause great harm. So buildings such as houses and churches and schools can be buried by the landslide, and many people can be killed, and roads can be blocked so that rescuers find it difficult to help. Now, I've put up another link for a YouTube video. It's National Geographic again, and it shows you the sheer harm that landslides can cause. So this slide has more information about landslides, and it can show you the process by which a landslide occurs. Just to note in point 3, we do have our case study in West Kerry. So the 3 landslides destroyed everything in their path, including the electricity poles. There was a bridge that collapsed and a large section of the road that you can see in the diagram below. So between the video and this case study here, it just shows you how dangerous a landslide.
Now, let me point out for students in 4th and 5th form who are doing Caribbean-related geography, CSEC or CXC, the general information that is being given at this point is helpful, but in the final video clip that is coming up, it will be more specific to the Caribbean, so make sure that you watch that video clip that's coming up, which more specifies the information as it relates to the Caribbean and the topic mass wasting.
Landslide can be. Now I would like you to do the last part of filling in the blanks. Again, this is related to landslides, and to remind you that it's been the same box for the 3 types, and you can't use the same word twice. To recap, mass movement is the...
Alright, as you can see, students, I made sure to skip over aspects of that video clip which are not really relevant to Caribbean students or CXC students, but the information is helpful anyhow. Remember to pause the screen where you feel it necessary and go over the exercises that were included. Now, as we close this presentation, I'm going to show you the most important video clip, and that is mass movement, specifically dealing with Caribbean students, CXC students, CSEC. So therefore, you will expect to hear more relevant information as it relates to you in the Caribbean who is studying CXC. So here we go.
So we are going to be moving to mass movement. So the syllabus asks us specifically to look at the definition and the causes and result of mass movements, specifically landslide and soil creep. So those are the things that we are going to cover, because that is exactly what the syllabus asks us to cover. So mass movement, definition, causes and results of mass movement. These are the things that we are expected to cover according to the CSEC geography syllabus. So mass movement. Mass movement is also called mass wasting. Mass in this particular case means a lot. It means that a lot of movement is taking place. So mass wasting is also known as mass movement. It refers to the movement of the weathered material. So remember, when we were looking at weathering and the definition of weathering, I stated that we must mention the in situ part, which is the fact that the material does not actually move, it just breaks down. So that material that has been weathered, this is where the material now moves through the process of mass wasting. So this is the movement of weathered material downslope because of the influence of gravity. And pay attention to the fact that it says downslope. So if it is just flat land and there is no slope at all, that weathered material would just stay exactly where it is. But if there is a slope, you will have gravity influencing the movement of things. And as a result of that, the weathered material, or the material that has now become loose from the rock breaking apart, it will now move through this process of mass wasting, right? So the syllabus asks us to look at fast movement as well as slow movement. Fast movement in the form of landslides and slow movement in the form of soil creep. So there are several different other types of slow movement and several different other types of fast movement, but the syllabus specifies that we should look at landslide and soil creep. So slow movements, I just dropped another example there, is rock creep. So just by looking at the word alone, creep, who you know creep?
Baby.
Exactly. And they're pretty slow. You have some babies that do some speed creeping, but babies are pretty slow. So once you see creep, you know that the movement is not very fast. It is very slow. It's a slow movement that is taking place. So rock creep, soil creep, those are all slow movements. Okay? So soil creep, as the syllabus asks us to look at specifically, this is a very slow but generally continuous movement of soil downslope. So it is a slow movement. We can't necessarily see it with our naked eyes. We can't look at it and see that the soil is creeping. We have to look at other evidence to suggest that the soil is creeping, right? So it is a continuous movement of the soil down the slope. So this normally happens in areas where the soil is damp. So what should I say now? Let me use I don't know what from your kitchen, but things, when you have water in it and it becomes damp, it gets heavier. It gets heavier. So if it is flour you add water, it's heavier. Rice and you add water, it's heavier. It's heavier than it usually is. So if we dampen the soil, then it's going to become heavier. So heavy things would move faster. The water itself also acts as a lubricant. So it makes it a little slippery. So it allows the soil particles to move as well. So that is where the soil creep would take place. So eventually, the movement of soil tilts fences, posts, and even trees. Soil will accumulate behind walls, etc. So these are the evidence of soil creep that is taking place. So for your exam, what we have seen so far, they've actually given this picture in the exam and asked for you to identify from the picture evidence of soil creep. There has been cases where they ask you to draw a diagram showing evidence of soil creep. So pretty much you would be required to draw this diagram that is here to show the evidence of soil creep taking place, right? So that is how I've seen them use evidence of soil creep in the past papers so far. So where soil creep is concerned now, it's usually on slopes that are less than 5 degrees. The rate of soil creep is less than 1 centimeter per year. So we can't really see it taking place. It's happening, but we cannot see it. So the only thing that we can really look at is the evidence of soil creep. So what causes it in the first place? Rain lubrication can cause it, and we mentioned that before with the water that is present. Freeze-thaw action can cause it, and we know what freeze-thaw action is from weathering. And then animals burrowing through the soil can also cause it, because they would be putting pressure on a particular area that would cause movement where the soil is concerned. Thermal expansion and contraction. So that would be as a result of temperature as well. That would actually cause the soil to contract and expand and cause movement to take place. So those would have been our evidence that soil creep is taking place. Some actual real life examples are like this. So these are gravestones. So the gravestone itself actually has moved. So, you know, sometimes you probably go to a graveyard to visit a family member that has passed, and you notice that the gravestone has actually shifted. It's just that soil creep is taking place in that particular area. The other example is the bending of these fences here. It is showing that soil creep is actually taking place along this roadway. We can see the bend in the electricity poles as well. Those are our examples of soil creep taking place. So the next movement is the fast movement. And there are some examples there. Falls and slides, just like they sound. When you think about it, they happen quickly, falling and sliding. So examples would have been rock falls, landslides, rock slides, etc. So the one that we are required to look at as per the CSEC syllabus is landslide. So landslides, a landslide is a sudden movement of rock or soil downslope under the influence of gravity. So you notice again that the word slope, the presence of a slope, is important in both soil creep as well as in landslide, because if we did not have a slope, the weathered material would sit exactly where it is. With that kind of movement would not be taking place. The mass movement would not be taking place. So the presence of the slope is very, very important, right? So that's it for landslides. We have different factors that affect mass movement. So when we say factors affecting, we are talking about the things that help it to occur, the causes of it, things that help it to actually take place. So factors that affect the mass movement is the gradient of the slope. So we mentioned slope earlier in both landslide as well as in soil creep. So the gradient of the slope, this really means the steepness of your slope. So the first one is the gradient of the slope, which is really talking about how steep your slope is. Then we have human activities, water, presence of vegetation, and earthquakes and volcanic activity. Just from the actual shaking movement that occurs as a result of this. So the vigorous shaking will cause loose materials to fall down the slope. So this causes the loose material to fall down the slope. Whether it is fast or slow, earthquake and volcanic activity would still cause that. So let us look at the gradient of the slope first. So gradient, we're talking about steepness, slope steepness. So if the slope is not very steep, so if it is less than 5 degrees in steepness, then we would expect soil creep to be taking place. But if you have a very, very steep slope, you are more likely to experience landslides. So if the material is going to be falling down the slope, if it is a very steep slope, it will fall faster. and more material will move. But if it is gentle, it's not going to go very far, and it will not move so quickly either. So you will have a creep happening rather than an actual slide. So in this diagram, we are seeing mud flows. We are seeing creep taking place. So this is a diagram that is similar to the one that you were shown earlier, where we are seeing the evidence of soil creep that is taking place. Landslides now, those would need to have a slope so all the material can actually run down the slope, and it would settle at the base of the slope. So the steepness of the slope is very, very important. Then we have human activities. So we carry out activities that causes landslides to take place or influences the movement of materials down the slope. So we are building things. We are cutting down slopes to build roads. We are cutting down trees to build houses, etc. So all of these activities affect or influence mass movement to take place. So first thing, removing vegetation from slopes. We know that vegetation has roots. We know that these roots, once they are inside the soil, they are holding the soil in place. They are holding the soil together. So if we are to remove those trees and remove the very thing that is actually holding the soil together, then the soil becomes very loose. So once the soil is loose, then it is likely to fall down. So it's like you're wearing a pants that can't fully fit you and you have on a belt. So in this case, the tree roots would have been the belt. So once you remove the belt, the pants gonna fall down because the material is now loose. It can't fit you no more, right? So similarly here, if we remove the vegetation, the material is now loose. So it is easy to just fall down the slope once we have removed the vegetation. The other thing that we do as humans, we build on unstable slopes. You ever drive through some places and you see some house catch up at some part? And you wonder to yourself, who put that there, sir? How them do that? Like nobody thinks it through. You wonder to yourself, right? So we build on unstable slopes, and because we build on unstable slopes, we put additional strain on the slope itself. So when we put that additional strain on the slope itself, it causes the slope to now fail. It causes it to actually fall down. Okay? So the next one is the undercutting the base of slopes to build roads. So think about it. If we have a slope like this, right? That is my slope, and I have my trees up here, so and all of that. I have my trees on my slope. And then now, I want to build a road. So I just come here so with a tractor and decide, say, all right, I'm going to just build a road right here so. So I start cutting out in here so. So all of this material now, all of this area now becomes empty. So this becomes my slope. What do you think is going to happen with the material that is on here? The material is going to become unstable and they are going to fall. They're going to fall in the road. So that is where you have rock falls and landslides, etc. And you will see people put up actual signs to say, beware of rock falls, when really and truly we are the ones that did it as human beings, because we undercut the base of the slope just so that we could build a road, right? So human activities play a major role in the movement of materials in how we can actually have landslides and those things taking place. Then we have water. Water acts as a lubricant. It makes things easier to flow. So when we have rocks like shale or clay, which becomes very, very slippery when they are wet, any material above a layer of shale or clay is just going to slide off when it becomes wet. So if we have a layer of, so say this is my slope, right? This is my slope, and these are my rock materials underneath. So this is just soil at the top there. Then this is my clay layer, and then I have some other material down here, right? So when it is raining and the water is percolating or coming through, seeping below, since this is my clay layer, when we have lots of material around clay, I don't know if you've used clay before or played with clay before, but clay is very, very, very slippery. So once you have the clay gets wet, everything that is above the clay is gonna just slide off. So all of what is at the top is going to just slide all the way off. So what we would end up with now is just the clay that is left there. So the water would have acted as a lubricant, and it would have caused all of that material to slip off. So in the Caribbean, as well as in other areas, but we would have heard about the Caribbean mostly, you would realize that we get our landslides after heavy rainfall. Yes, so once we have heavy rainfall, you can expect that some place in the country, somewhere, you are going to have material that is sliding down the slope as a result of that. So heavy rainfall, it saturates the soil, so it gets a little heavy. And it also reduces the friction, so it makes it slippery now. So it increases the possibility of landslides. So if you have an area that already had a slope, and then you already had some loose material on it, once it starts to rain, that loose material is just going to wash away. Some other factors that influence landslides, when there's a thick layer of unconsolidated material. So unconsolidated means loose. But this is the geographic term for it, so you may see it on your exam somewhere. So it just means loose material. Right? You know, sometimes when you pull out a tree or pull out a little weed or something, how all of the soil just comes up, it just loosens up really quickly. So that would have been your unconsolidated material. So it's not solid, it's not compacted. So this thick layer, once you have a thick layer of loose material on the slope, such as sand or clay or volcanic ash like we had in St. Vincent recently, once you add some water to that, then the landslide will take place. So we know that, well, we should know that if we add water to volcanic ash, what do we get? Start with the L.
Lahar.
Lahar. Very good. Lahars. So once you add water to that, you will have gotten lahars. Once you add the water to lots and lots of clay or sand or other loose soil, you will have a landslide. So all of this material is just now going to run down the slope, right? So that's another factor that influences landslide. Then we have when bedding planes are roughly parallel to the slope surface. So it makes it easier for the material to slide along the bedding planes. So that little diagram that I drew a while ago with this one, with the clay. So once the bedding plane is parallel, So they're all running in the same direction, but they're not meeting. Once they're parallel, it makes it easier for an entire layer to actually just slip off. So materials can easily slide along the bedding plane, especially if we have an impermeable layer that is underneath the permeable layer. So if we have a layer that the water cannot pass through underneath, and then there is a layer that the water can pass through, it means that it's going to block somewhere because it cannot go through the layer that is impermeable. So all of that permeable layer is now going to get very, very saturated. In other words, you're going to get full of water. And then that top layer is now going to just slide off, and all of that material is going to go with it. Okay? Whenever you get almost anything in geography that asks you about effects of a natural disaster, effects of any one of these things, you can always put loss of life, destruction of habitat, destruction of property, destruction of economic activity. So no matter which kind of disaster it is, all of them cause loss of life, destruction of habitat, destruction of property, and disruption of economic activities. Well, they also cause displacement of animals and people, all of them. So it doesn't matter which one they ask you, you can always write the same thing. Question: explain one natural factor that influences the occurrence of a landslide. Explain one natural factor that influences the occurrence of a landslide.
Okay, students, there you have it. The 3 video clips that were combined. Let me thank and give credit to those teachers who created those video clips, helpful video clips. No taking away from their efforts and their right to the creation of these materials. But let me hope that they were helpful. And as you study the topic mass wasting, compare what you have in your notes and what you have done in your own class with what you watch in those 2 video clips. My advice is to go over the video clips more than once, pause the screen, make note of important points highlighted on screen, and compare with your notes. Check the vocabulary, keywords that are used. Make sure you understand the meanings of the various words that are used. And success to you as you prepare for your CSEC or CSEC exams. Thank you for listening.